Hello there, Algebra 2. Today we're doing 3.3 systems of inequalities. Objective, to solve systems of linear inequalities. Solving a system by using a table. Assume that G and M are whole numbers. What is the solutions of this system? At this time, at that point in time, or at this one, we're going to use a chart. So, I'm going to go with the bottom one because of the fact that my variables are less than 20. If I go greater than, can't my numbers always get bigger and bigger and bigger and bigger? I mean, realistically, smaller it could too if I go negatives, but I'm not going to go negatives. Okay, so I'm going to do my G first. What are some factors that work for G? Well, if I put in 0 for G, will that make this statement true? Possibly. Okay, if you're just looking at the G and not the M part, that would still be true. I could try 1. 1 would still be true. 5 would be less than M. 2 would work because 10 would still be less than. 3 would work because 15 would be less than 20 or equal to. And 4 would work just because of the fact it's equal to. Now, I need to make the other part of the equation work with these numbers. So I'm going to find my M values that work with G. Okay, if I have 5, which would be 0, I can have 0. Because 0 times 0, or 0 times 2 is 0. 0 times 5 is 0. So we're going to get 0 is less than 20. I can get 1. Okay, once again, my 5 times G is 0 plus 2 times 1, which is 2. I can do 3. I forgot 2. Alright, let's try 2. 2 goes in there. Once again, the first part is 0 plus 2 times 2, which is 4, which is less than that. 3, once again, first part is 0. By subbing in for G on the bottom one, and you get 3. Well, it does work because that'd be 6. 4 would work because that's 8. 5 would work because that's 10. 6 would work because that's 12. 7 would work because that is 14. 8 would work because that's 16. 9 would work, and 10 would work. Anything above 10 will not. Okay, now the next one you have, it is 5 times 1. So every time that front part of the bottom equation is going to be 5. So if I put in 0 for the second part, I'm going to do 5 is less than 20. I put it in for the next part, I'm going to put in 1. 5 plus 2 is 7, so that works. 3 or 2 would go, 5 plus 4 is 9. 3 would go in there and you get 6. Plus 5 is 11. 4 goes in there, you get 8 plus 5, which is 13. 5 goes in there, you're going to get 15. 7 goes in, I forgot 6. 6 goes in there, you're going to get 17. 7 goes in there, you're going to get 19. Okay, that should do everything here. Sub in a 2 for the G, you're going to have 10 there. So 0 will work because that'll be 10 is less than 20. 1 will work because it'll be 12 is less than 20. 2 will work because you have 10 plus 4, which is 14. 3 will work because it's 16. 4 is 18. And 5 will work because it makes 20. If you have 15, you're going to have 0 would work. So that would be 15 is less than 20. 1 will work because that'll be 17. And 2 will work, and this one will be 0. Now, we got to make the top one work. Okay? themselves work. So, if G is 0, what numbers can M be? Well, if you have 0, you have to be greater than 7. So I can eliminate all these because of the fact I'd be adding 0. It isn't until I add 6. So this one, this one, this one, this one, and this one work. Okay? Now, also, on this one you have 1. 1 plus 5 would work, 1 plus 6 would work, and 1 plus 7 would work. We've got 2 here, 2 plus 4, like that. And I think that is it. Those, the ones that are underlined, are the ones that would work as solutions. So you'd have 0, 6, 0, 7, 0, 8, 0, 9, 0, 10. You'd have 1, 5, 1, 6, 1, 7 works, 2, 4, 2, 5, and that would be your solutions that work both in these inequalities. So if you would graph this, you would have something that works there. Okay? Do the next one. Once again, on the next one, I am going to go where it is less than, so the first one. So, you have x and you have y. On the first one, those values are less than. So, if 0 or if x is 0, you could have 0, 1, 2, 3, and 4. Okay? If it is 0, what numbers can go in for y? Well, 0 could. 1 could, right? Because that's just going to give you 2 is less than or equal to 4. 2 could, because that gives me 4 is less than or equal to 4. We're done. Okay, we have 1 here, so my x value will be 1. Okay, if I have 0, 1 is less than or equal to 4. If I have 1, I'm going to get 1 plus 2, which is 3, is less than or equal to 4. If I put in 2, I'm going to get 5. Okay. Okay, now 2. Okay, 2 goes in there, okay. 0 will work, and 1 will work. Okay, 3, 0 will work. Other than that, nothing will work. And 4, 0 would work again. Good. Well, we need to make the second equation correct. Okay? Now, right off the bat, this one isn't necessarily easy because of the fact that you don't have it. Well, you could move that x over to the other side by adding, and you get x plus y is greater than or equal to 1. Okay, if I put in 0 for x, this is 0. If I put zeros in for both of that, is that greater than or equal to 1? No. But if I put in the 1, that is a true statement. If I put in the 2, that is a true statement. Okay. Okay, once again, you put in the 0, or 1 and 0, that'll work. You put in the 1, 1, you should get 2, which is greater than or equal to 1. You put in the 2, 0, that'll be greater, that'll be greater, that'll be greater, and that'll be greater. Those are all my solutions. So actually pretty much every one of the ones I chose there will be a solution. Okay, using culture centers and sponsoring a concert to raise at least $30,000 for the city's youth service. Tickets are $20 for balcony seats and $30 for orchestra seats. If the center has 150 orchestra seats, how many of each seat must they sell? Okay. So, the only thing that I don't like about how this is worded is the fact that you got one equation over here that you're going to have 20 times B, because that's going to be my balcony ones, and plus 30 times O is less than or equal to $30,000. Okay? The tickets, okay, if the center has 500 orchestra seats, how many of each seat do they sell? And that must be more of, that's how many seats they have in general. So you have 500. You can fill at least 500. Probably cannot go over it. You'd have balcony plus orchestra. Make that a little swan. Alright, is going to give me 500. Okay. I do not think I want to go through and do a chart on this one. I think I personally would choose probably to graph this or do like elimination or something along those lines if I was choosing. Bottom line, call me lazy. I just don't think going the chart would be a smart idea here. Personal opinion, maybe I am wrong. Okay. Or also go to Desmos and graph these. That would probably be the easiest way is to use a graphing calculator or Desmos. And I don't know why I did not remember that's what the book did. Okay. So you have 20 B plus 30, and we don't want to go B. Let's go with that is X. And this is going to be Y. Okay, we need to zoom out. Zoom out. So, this would be the graph in which I would be looking at. Right here, in my opinion. Let's go see if I can get it and blow it up. This would be the graph I would look at. The reason for it is in quadrant 1 because we can't have negative people, we can have negative dollars, but preferably not. Anything that's in both of these, like this, in this coordinate number 1, would be the answers. Okay? Okay. The other thing that you're doing, a pizza parlor charges $1 for each vegetable and topping and $2 for each meat. You choose at least 5 toppings on your pizza. You have to spend $10 on or spend on toppings. How many points can you have? Okay, so going to this, and this is going to be the same thing. This will be a little easier to graph, but so you're spending $1 on veggies plus $2 on meat, and that has to be less than or equal to $10. Okay, and you want at least, so veggie plus meat has to be at least 5 different ones. Okay, this would be another spot where I would take these two equations and type them into decimal. This one would not be to the point that you could not do it on your own, but I think it would be just as easy to go on decimal and see, because basically what I want you to do in a word problem is understand how to set it up, and we prove that right now. What is the solution? Our solutions of the system of inequalities. Alright, this is my last slide. Okay, so we have a couple things going on here. Okay, and obviously I could graph these out, but I think it'll be easier for you watching this video if I do it on Desmos. Okay, so you have y is less than or equal to 3, and y is less than or equal to 2x minus 1. What is this equation with absolute value takes us back to? Well, we go back to our parent function. We stretched it by 2, so we're going to have a rise and a run of 2 over 1. It'd be up 2 over 1. Okay. We're going to be shifted to the right 1 because of this number right here. So before we even start, our vertice is going to be to the right 1. And then, like I said, you're going to go up 2 over 1. There's my point. Up 2 over 1. There's my point. And then it'll look something like this. And your main function would have been right here. And it would have been not quite as dramatically up. Okay, that's all you have to remember on that. Like I said, I will graph it on Desmos because then I don't have to move my deal. Plus half the time you can't see it with my markers anyway. Y is less than or equal to 3. Y is less than or equal to and it would look something like this. Obviously, everything below where y is equal to 3 and below is shaded here. The other thing, we got our v, like I said, we're shifted over. I want to zoom out. 1, so it's a 1 to 1, so it's easier to see instead of go by halves. So you have this. Okay. You can see that it was shifted over 1. If you go up 1, 2, and over, there's your points. Just start graphing that. It is there. Like I said, quite capable of drawing this on your own, but you have to understand this stuff too, of why you're doing it and stuff like that. I would use Desmos to check myself if I'm at home, because it is a tool to use to make sure you understand it. That does not mean just use Desmos the whole time. Okay. Get your homework to you. There's your homework. Good luck.